Welcome to another episode of OpenAirInterface tutorials. As I promised before in the last video, I'm going to talk about the Magma software. So, if you are new in OpenAirInterface tutorials, please don't forget to hit the subscribe button. And also, if you want to receive notifications, don't forget to hit the ring bell. So let's start with the deployment scenario. In this case, I have two computers. The first one is for the InnoDB using the OpenAirInterface software, and the second one is the orchestration, the NMS and the access gateway using the Magma software. Both of them are connected through a switch, and it is connected to a router that has a gateway 192.168.0.2. In order to send radio signal to UEs, and I'm using a USRP B2000 Mini through a USB 3.0 interface. So the USRP has an antenna that transmits the signal through the air to the UEs. So now I have to define the project Magma. Magma is an open source implementation of a mobile network core that supports Wi-Fi, LTE, and 5G networks. Magma leverages open source software and commodity hardware to help operators manage their networks efficiently and costly. Magma can also be federated with existing cellular networks to allow networks to be cost-effectively extended into remote areas. And here I have a recommendation is to take the Linux Foundation course LFS 166X called Introduction to Magma, Cloud Native Wireless Network to understand a little bit this project. So when we start working with this project, the first question that we have in mind is why Magma is too hard to implement. And the most important reason is there is no coherent documentation. You need at least Linux administration and a basis on Docker, Docker Compose, and Kubernetes to find basic problems. Additionally, you need to know about principle of cellular networks. If you don't know anything about it, you can check this link that is 5g.systemapproach.org index.html. You will require to know how to configure a network on a Linux machine, and it is important to know very basic commands such as grep, find, netstat, ifconfig, service, systemctl, journalctl, vi, cat, etc. My second recommendation is to use the latest version of Magma because a lot of bugs are fixed and new extensions are available, such as Narrowband Internet of Things, 5G non-standalone and standalone, and more. Now it's time to talk about the Magma roadmap. So Magma delivers new software each 3 months approximately. It started from release 1.4, governed by Facebook. The governance was moved then to the Linux Foundation. At this moment, when I am recording this video, releases 1.4, 1.5 and 1.6 are available. So, for example, you can run 5G non-standalone and LTE use cases. Remaining months, we're going to see new releases, for example 1.7 and 1.8, and we are going to observe new features such as 5G standalone, narrowband Internet of Things, and finally, the access wait gateway containerized. What is the Magma place to take action on cellular networks? To answer this question, I have to see the architecture of cellular networks. So they are composed of the access network and the core network. Magma is on the converged core network, and you can find LTE, Wi-Fi, and 5G entities. Also, you are able to deploy on cell site, on private cloud, or finally on public clouds. The first part of the Magma Converge core is the orchestration and the network management service. It is a central point of control and mobility management functions for a mobile Packer core. It uses a graphical user interface for the NMS for provisioning and operating Magma-based networks. The second part of the Magma Converge core is the access gateway. It implements user plane and mobility management functions for a mobile packet core, and you are able to see LTE, Wi-Fi, and 5G entities for this function. The last part of the Magma Converge core is the Federation Gateway that allows Magma to extend and interoperate with existing mobile network of other operators such as T-Mobile. After successfully install Ubuntu 20.04, we need some prerequisites such as Docker, Docker Compose, Background, VirtualBox, and Go before start installing Magma. Not only we need the applications mentioned before, but also Python and the kernel. The kernel should be lower than 5.6, and my recommendation is to use the kernel 5.4. Let's observe now how these prerequisites are installed on Ubuntu 20.04. The easiest way to install software or packages on Ubuntu is by using the Advanced Package Tools or APT. Then we follow the recommendation of the Docker web page to install Docker and Docker Compose. So in this part I have a problem with the Docker service. So the reason is because previously I didn't delete completely the Docker installation. But you are going to see that if we use the command sudo service docker restart, we can solve this problem. Then we continue with the installation of the Docker Compose as suggested by the Docker webpage. Before successfully installing all the prerequisites of Magma, we continue with the installation of the access gateway. But before of that, we need two physical interfaces that will change their names to ETH1 and ETH0 when the access gateway script is launched. So the first interface is ETH0 that has an IP assignation based on DHCP, and ETH1 has a fixed IP that is used to connect the eNodeB, gNodeB, CURCC, BBU, and more to the access gateway. So the installation, first we need to go to the root user using the su command. Then we download with a wget the access gateway script. Finally, we launch that script. In this case is the agw underscore install underscore ubuntu.sh. So the command is bash that name of that script. My recommendation is to use the latest version of Magma because it brings us a lot of new features. The installation of the access gateway on Ubuntu using a bare metal is the following. Please be aware that Ubuntu has to have a user called Magma, and the password of this user should be also Magma. Additionally, for the root user, please use the same Magma password. Here we opened the Access Gateway install script to modify some items before install the access gateway. So in this case, I will put a sleep command in order to stop 20 seconds before the reboot of the computer. Here I am highlighting the two network interfaces we need before installing the access gateway. So after the installation of the access gateway, I need to verify that this installation was successful. Uh, for doing that, after reboot of the computer, I use the command journal ctl-fu access gateway underscore installation. So it has to inform me that the installation was successful. Then I need to check all the Magma services using the sudo service magma add status, because we will use Docker containers for the orchestration. We need to edit the control proxy YAML file using sudo gedit. Also, you can use vim or vi. It doesn't matter, but it's the same. And the address is slash bar slash opt slash magma slash configs slash control underscore proxy dot yaml. So we modify for the cloud port, it should be 7443, and the bootstrap port should be 7444. Finally, make sure that you have the correct root ca.pem certificate. So it is a good command we can use to check that. And it is diff. So if we use diff home magma dot cache dot test search root ca pem versus bar opt magma search, if we don't see anything on the terminal, we are sure that they have the same information. But if you see, if we see information after executing this diff command, so we need to change or replace the rootca.pem file. So to do that, you need to use sudo copy magma home magma dot cacheta cert root c8 dot pem to the folder bar opt magma certs. So finally, let's see the installation of the network management system and the orchestration. So the first thing we need to do is to download the Magma repository. Then we check out the last release, that is v1.6. Then we go to the folder home magma orchestration cloud docker and run the build.py-all script. After that, we go to the Docker Compose YAML and we modify the fluentd ports as we see down below. After that, we run the run.py-metrics script, and this finally creates the images for the network management system and execute it on the host. After that, we continue with the folder home magma nms app packages and magma lt. We run a docker compose build magma lt, and it creates the images. But also we need to modify the docker compose YAML in magma lt to change the ports. In this case, you need to change the port 80, 81, 80, 81.2, 80, 82, 80, 81. Then we run docker compose app -d and we execute the images. Finally, to get access to the NMS, we need to run the script called dev underscore setup dash sh. So with that script, we create the user and the password to log in into the NMS. Finally, we need to modify the etc host file and add the following lines down below. With that in mind, we can go to the https magma-test, and we use the user admin dot magma.test, and the password is the password1234. So here the recommendation is each time you reboot your PC, you need to run the following command to restart Docker containers of the Magma orchestration. So it's Docker restart, and this information after restart selects all the containers that need to be restarted. I will show an example in the next video how to use this Docker restart command. To log in into the NMS, please go to the web browser and put https://magma-test.localhost or without localhost. Finally, everything is going perfectly, so the idea now is to configure the radio access network, the core network, the subscribers, and the API. However, I'm not going to show this information in this video because it's going to become too long. So for the next video, I am going to show how to configure OpenAirInterface and Magma both together to create a small deployment composed of a COTS UI using a smartphone, a inodb using OpenAirInterface, and the core using the Magma software. Do you have questions? If you have any, please write the question down below this video in the space dedicated for that. If you are new in this channel, please also don't forget to subscribe the channel, then hit the bell and enable notification for future videos.